Hi, welcome to Mrs. Thompson's classroom again today. We're going to continue learning how to graph trig functions. Specifically today we're going to be looking at the cotangent function. Now cotangent is 1 over tangent. It's the reciprocal of tangent, or that means it is cosine over sine. So if we remember our unit circle, we can label points at 0 degrees, 90 degrees, which is pi halves, 180 degrees, which is pi, and then 3 pi halves down here at the bottom. And those are where cosine and sine are 1s and 0s. So those are really interesting because then cotangent is going to be 1 over 0, making it undefined. Or over here at pi, it'll be negative 1 over 0, also undefined. Now, rational functions where the denominators are 0 have asymptotes. So the first thing I'm going to do is I'm going to mark those two values as asymptotes. So here's 0, and we'll call this pi. Okay, now we can plot some other points. So we also know that at pi halves, cosine is 0, sine is 1, so I get 0 over 1, which is 0. So at pi halves, I'm going to plot a 0. Now at pi fourths, I'm going to get 1. Okay, at 3 pi fourths, I get negative 1. And so I get a shape that looks like this. And this is one cycle or one period. Okay, so we can repeat that as many times as we need to. Okay, so we can also see that this means our range is all reals. Okay, our domain is x not equal to what? Well, it would be at 0, at pi. I'd have another asymptote over here at 2 pi or at negative pi. So we could say that our domain is not equal to multiples of pi where that multiple is an integer. And that's exactly where our asymptotes are as well. And the zeros, therefore, are at all the pi halves. And we would have to make sure k stays an odd integer so the fraction doesn't reduce. Okay, so how do we transform this function? So all the rules that we've been using for sine, cosine, tangent are all going to still apply. So this value inside here, we're going to have something set up like this. Okay, so the number inside here is how we find our period, because this multiplier causes a horizontal stretch or shrink. So we're going to be stretching the graph or shrinking it horizontally, causing a change in our period. So the period is normally pi, and then we divide by 2. If there was something added or subtracted, this number would be the phase shift. So in this particular example, it's 0. And my A is 1. Okay, so let's mark 0. It always starts, cotangent starts at an asymptote. And so that asymptote is going to be at x equals 0. So I mark that. Okay. Pi halves is the period, so I'm going to go pi halves from 0 and mark another asymptote. And I could do that same distance as many times as I decide I want. So I'm just going to do 4 of them. Now halfway in So that means my end is going to be phase shift plus period. So that gives me x equals pi halves. So that's how I marked my asymptotes. Then my middle is going to be a 0. So where is the middle between 0 and pi fourths? So 0 and pi halves divided by 2 gives me pi fourths. And so there's my 0. So halfway in between each asymptote, I'm going to get a 0. Okay, now we remember that cotangent comes down like this. So halfway on the left side of the 0 is going to be where it equals a, which in this case is 1. And halfway between the 0 and the asymptote on the right side is where it'll be -1, and it'll go down towards the right-sided asymptote. And so each one of these is going to look just like that. So the A value in tangent and cotangent isn't a amplitude, but it does tell us how steep the curve is. Okay, all right, let's do another one. In this case, I do not have a period change, so the period is pi. I do have a phase shift, and it's going to be pi fourths to the right. So I'm going to mark pi fourths, and I'm going to put an asymptote there. That's my start. Okay, then the end will be at pi fourths plus pi. Well, pi is 4/4 because it's 1 pi. And so I'm going to move over 1, 2, 3, 4, and that'll put me at 5/4. Halfway in between, so just use your tick marks here to find the middle, and I'll place a 0. Halfway in between there, I would put my A value, so I'll mark 1 and -1. Now, there's an interesting thing going on with this curve and this negative. It causes a reflection. So instead of going to 1 on the left-hand side, I'm going to go -1. And instead of being a decreasing function, it'll be an increasing function. And interestingly enough, a negative cotangent is going to look like a tangent with the asymptotes in the proper places. So I can go this same distance from here to here was a period of pi. So I'm going to go the opposite direction, that same amount. I'm going to place my 0. I'm going to place those 1s, and then I can connect the dots. And I have 2 cycles. All right. Now this one has another added feature, and this 3 in here is going to affect the period. So normally the period's pi, but now because I have a multiplier on the inside, I'm going to multiply by 1/3, and so I get pi thirds as my period. This pi fourths is still my phase shift, and it is still to the right. So I'm still going to start at pi fourths and mark an asymptote. Okay, now in order to be able to count my tick marks though, I need a common denominator. So the period here is actually 4/12, and the phase shift is actually 3/12. So let's remark my grid in 12ths. So I'll go 1/12, 2/12, and this will be 3/12, which is pi fourths, and that's where my asymptote goes. Okay, the period is 4 of those, so I'm going to go 1, 2, 3, 4, and mark another asymptote. I can also go 4 to the left, 1, 2, 3, 4 and mark an asymptote. Okay? The midpoint, remember, is your start plus half the period. So that'll put me at 5/12. And you can see that it's halfway in between these asymptotes. And so I could also find one here. Okay, the other way to find a midpoint, so this is phase shift plus half the period. The other way to find it is start plus end divided by 2. Those end up being the same thing. Okay, this is a positive cotangent with a 1 as an A value, so I'm going to be going down as I was before from 1 to -1, and I'll be coming down, and I'll be coming down. And there's 2 cycles. And you could continue and draw more cycles if you want. I could go 1, 2, 3, 4 again, find the midpoint, and draw another one. And you can do as many as you want or need to fill your graph. Okay, this one is slightly different in the fact that there's no parentheses here, so the 2 has not been factored out. So what I need to do is I need to divide the 2 out. So what is pi thirds divided by 2? Well, that would be pi sixths. So it ends up looking like this. And so my phase shift is the pi sixth. And we're going to go to the left. So I'll make it negative. Okay? And then my period is pi divided by 2. So the first thing I do is I mark pi sixth, negative pi sixth. Okay. I get this period in terms of sixths, so this would be 3/6. So I'm going to mark my asymptote at the start place, at my phase shift. And then I'm going to go the period 1, 2, 3, and mark another one. 1, 2, 3, and mark another one. Okay, 3 and mark another. And go the opposite direction and mark another. As many as I want to fill my space. Okay, now halfway in between my midpoint, my 0, again, is going to be the phase shift plus half of the period. Okay, so if I just look at the graph, I'm going to come in, and I end up, my midpoint is right here. So if my tick marks are in sixths, halfway in between those tick marks is going to be a 12th, and that's what this ends up being. I would have to get a common denominator of 12ths. This right here would make pi fourths, so it would be 3/12. And so I end up at pi 12ths for that first 0. Okay, again, my A value is 1, so I mark 1 and -1, and I'm going to go halfway. And you don't have to be real precise with those marking of A. Just know that if A gets bigger, it's going to look steeper. Okay, and so then we do the same thing between each of the asymptotes. So I find the middle, and then I'm going to come down. I find the middle, and I'm going to come down. And I can do it and fill up my graph. So tangents and cotangents are pretty easy to fill up the space pretty quickly. I just did 5 phases right there. Okay. All right. So hopefully that gives you a little explanation of how cotangent works. Just remember that, like all of them, we have A, and then we have bx minus n like this. Or you might see it like this, and C is going to equal N N will equal C divided by B. Okay? And that is my phase shift. Okay? All right, so I will see you next time. We've got videos on secant coming up, and then cosecant, and then we'll have completed graphing all 6 of our trig functions. So I will see you next time.